In this video, we're going to be looking at linear functions and finding the y-intercept, also known as the initial value, and the slope, also known as the rate of change. And we're going to do this from three particular representations. I need you to be able to do this from a graph, from a table, or from an equation of a certain form. So let's talk about finding the y-intercept first. So the y-intercept is just the y value when x is 0. And there are three ways to find this given whatever representation we have. If we have a graph, it's where the graph crosses the y-axis. If it's a table, we're looking for the y value next to 0. And if we have an equation of the form y equals mx plus b, the y-intercept is the constant term, whatever b is. So looking at an example, let's find the y-intercept of this linear function. So we have three different representations. We have an equation, we have a table, and we have a graph. So let's find the y-intercept. Now the easiest one to find the y-intercept from is the equation, as long as it's of the form y equals mx plus b, and there will be other forms, so you do have to check for that. As long as it's of that form, the constant term, the number with no variable, is your y-intercept. So the y-intercept for this linear function is just 1. Now, don't get too excited about how easy that is, because sometimes you'll have the equation, sometimes you won't. Sometimes maybe you'll just have the table. And if you're looking for the y-intercept from the table, what you do is you look in the x column and you look for 0. And there is 0. The y value that's with 0 is going to be your y-intercept. There it is, 1. So I can find it from the equation, I can find it from the table, or what I can do is I can find it from the graph by looking at the y-axis, the one that runs up and down, and I want to look at the y value where that crosses the x-axis. And the y value when the graph crosses the y-axis, excuse me if I said x there earlier, the y value when the graph crosses the y-axis is 1. So guess what? That's my y-intercept. And that's pretty much it for the y-intercept. It's what's across from 0 in the table. It's where the graph crosses the y-axis, or it's the constant term when I have y equals mx plus b form of a line. So let's talk about the harder one of the two, slope. The slope of a linear function is for any 2 points, take whatever 2 points you want on the graph as long as they're different, it's the change in the y value divided by the change in the x value. Now, that's written as an equation like this, but don't let this scare you. That triangle is called delta. It's a Greek letter. It's basically a Greek D, is all this is. And it just means change. So that just asks you about the change in something. So delta y simply means the change in y. Delta x means the change in x. So we say slope is delta y over delta x. How much the y value changes divided by how much the x value changes. And if we have an equation like y equals mx plus b, the slope is just the coefficient of the linear term, m. And that's it. So let's try it. Here we're supposed to find the slope of the linear function. Slope we abbreviate with m for reasons that I won't get into here. And so our slope is just going to be the coefficient from our equation, so that is whatever's in front of the variable. So in this case my slope is 2. Easy enough. But then how would I find that if I was looking at, say, the table? So what I would do is I would take my equation, slope is delta y over delta x, and I pick any 2 points I want. Let's say I pick this point and this point, an x and a y value. So what I'm going to do is I'm going to find my change in y. Y went up by 2. It went from -3 to -1, so my change in y is plus 2. My x went up by 1. There it is, from -2 to -1. So up by 1 would be plus 1. So my change in y is positive 2. My change in x is positive 1. 2 divided by 1 is 2. Easy as that. And this works for any 2 points I pick anywhere on the table. So what if I pick this point and this point? They're not even next to each other, but let's see if it still works. My change in y goes from 1 to 5, so that's plus 4. My change in x, I went from 0 to 2, so that's plus 2. 4 divided by 2 is still 2. I can do this for any 2 points I want. It's how much the y value changes divided by how much the x value changes. And I can use that same idea over here on the graph. Take any 2 points you want. Maybe I'll take that point right there and that point right there. I want to know how much my y changes and how much my x changes. So I'm going to draw this triangle. The up and down tells us how much the y changes by. So here the y changed by 1, 2, 3, 4, and it went up, so that's positive 4. My x changed by 1, 2, and it went to the right, so that's positive 2. My slope is change in y, plus 4, divided by change in x, plus 2. 4 divided by 2 is still 2, no matter what I do. Now, that I think is the best way to understand slope. It's the change in y over the change in x. However, a lot of students kind of need something more formulaic to help them, and surprise, there's a slope formula. So if I have any 2 points, x1, y1, x2, y2, whatever point you want, this slope formula, slope equals y2 minus y1 over x2 minus x1, will help you find that. Now in reality, this does the same thing as my delta y over delta x. y2 minus y1 will just tell you how much the y changed by. x2 minus x1 just tells you how much the x changed by. But it's a little more direct in how you would calculate it. So let's take a look at it. Find the slope of the linear function. I can very easily do this by looking at the equation. So I know my slope has to be -3. But let's look at using the slope formula to find this. So I can pick any 2 values I want for the slope. So I'm going to pick numbers that are positive if I have them, because that just makes things a little more simple. And we'll throw in this one negative because, hey, why not? So I now have my points, and I want to go ahead and label them. This would be an x, and this would be a y. This would be an x, and this would be a y. This one comes first, so I'm going to say this is x1, y1, and this would be x2, y2. And now I can just use my slope formula. Slope is y2 minus y1 over x2 minus x1, and I can replace those variables now with numbers. y2 is -2, so -2 minus 4 over, and then x2 is 2, x1 is 0. So -2 minus 4 is -6. 2 minus 0 is 2. -6 divided by 2 is -3. And so I can see that gets me the same slope that I got from looking at my equation, which is nice to know that that works. The same process works for a graph as well. I can take any 2 points on the graph that I'd like. Let's say that I take this point right here and this point right here. So that's the point 0, 4 and the point 1, 1. I can label these points. We'll call that x1, y1. Notice the 1's have to go together there. x2, y2. And now I can substitute them into the slope formula. So I can do 1 minus 4 over 1 minus 0. 1 minus 4 is, of course, negative 3. 1 minus 0 is 1. Negative 3 divided by 1 is negative 3, which happens to be the same thing that we got earlier. So now what I can do is I can find the slope, or the y-intercept of everything. I know here I'm only asking for the slope, but let's find the y-intercept too. So the slope, if I want to find it from the equation, I look at what's in front of the variable. So here it's going to be 2. My y-intercept is going to be the constant term, so in this case, negative 5. Now to find my slope from a table, I pick any 2 points I want. I'll take these two right here, and I need to find the change in y divided by the change in x. Well, here the y went up by 2, and here the x went up by 1. So my slope is going to be my change in y over the change in x. Always remember y on top. And so here I would get positive 2 divided by positive 1, which is a slope of 2. If I want to find my y-intercept, it's the one right across from 0. I can look at my graph. The y-intercept is the y value where it crosses the y-axis. So negative 5, hey, that's what I got up there. Good stuff. And then for my slope, I take any 2 points, and then I see what was my change in y, what was my change in x. So my y went up by 4, my x went up by 2. Y over x, 4 divided by 2, is of course 2. And so using this, you can now find the slope and the y-intercept of any linear function from any of these 3 representations.